Hello students, as we have completed chapter 4 complete explanation including the workbook part, here I am going to present you the videos related to chapter 4 which will help you in analyzing the chapter in more depth. Okay, so watch these videos very carefully and try to make out the notes out of those videos. This will contain the entire textbook and the application part, reflection of concepts part. All the questions can be answered by watching these videos which I am going to link up. Okay, so do watch them and if possible try to save them with you only. Thank you.
Hello friends, this video on metals and non-metals part 8 is brought to you by examfear.com. No more fear from exam. So now it is time that we talk about the chemical properties of metals, because in physical properties we just spoke about the appearance, the external properties, the external behavior of metals and non-metals. Now we will see that how these metals react when they come in contact with some other chemical substance. So how that reaction happens and how those reactions are different in metals and non-metals. So that is what we are going to discuss in chemical properties of metals. So first of all, let us talk about how metals react with oxygen. Now where is oxygen present? Oxygen is present in the air. So if the metal is exposed to air, it should react with oxygen. So let us see how exactly it happens. Now, almost all metals combine with oxygen to form metal oxides. So, metals react with oxygen and they form metal oxides, and these metal oxides are basic in nature. So, we will talk about that later. Now, let us look at some of the chemical reactions. So, let us see how different metals react with oxygen. Now, any metal reacts with oxygen to form a metal oxide. So let us take some examples. Let us suppose if you consider the metal magnesium. So magnesium combines with oxygen to form magnesium oxide, that is MgO. So if you want to balance the equation, this is how it would be. So in fact, you would have seen this. If you want, you can perform this experiment in your laboratory where you take a magnesium ribbon and burn it. So when you burn it, so obviously it is reacting with oxygen because burning happens in presence of oxygen. So, and then what do you get? You obtain ash. So the ash which you obtain, that is nothing but this magnesium oxide. Not only magnesium, you take examples of other metals. For example, you take copper. So copper reacts with oxygen to form copper oxide. You take examples of aluminium. So aluminium also reacts with oxygen to form aluminium oxide, that is Al2O3. So all the metals will form metal oxides. In fact, formation of this metal oxides can be evidently seen as well. So let us take the example of rusting. Have you ever seen that when any object which is made up of iron is kept outside, exposed to air and water for a long time? Or let us say you have some iron say bucket or iron vessel and you have left it outside. So obviously it is exposed to oxygen, it is exposed to air, and let's say that the air is moist, so the air has water. So whenever iron comes in contact with air and water, what happens? Rusting takes place. So you will see that on that iron bucket you can see some reddish color layer is formed. So that reddish colored layer which is formed, that is nothing but rust. So this rust is the result of reaction of iron with oxygen in presence of water. So let us talk about rusting. Now rusting always happens in presence of oxygen and water. So that is why we say moist air. So we will talk about iron. Now in case of iron, how the exact reaction takes place. So iron is Fe. This is iron. So iron reacts with oxygen in presence of water. So it could be moist air. Oxygen plus H2O could be moist air. It could also happen that the air is dry but there is some water droplets on this iron substance. So what will this form? This forms iron hydroxide, that is FeOH whole 3. So this is basically iron hydroxide. So if you want to balance the equation, this is how it would be. So we have balanced the equation. Now this iron hydroxide later dehydrates, that is, it loses all its water content to form Fe2O3 H2O, and this substance is nothing but, this is rust. So the reddish color layer or the reddish color powdery substance which is seen on the surface of iron objects is nothing but this Fe2O3 H2O, that is rust. So this is how rusting of iron takes place. And do you know, you would have seen this kind of rust in case of bridges and all. Bridges are made up of iron. So you'll see the corner of the bridges, they get rusted when it becomes quite old, because it has been exposed to air and water for a very long time. Now in order to prevent rusting, these days there is a protective layer on top of iron of another metal which does not form rust. So that means rusting can be prevented. Now iron is not the only metal where rusting takes place. You can also see rusting of copper. If you look at copper vessels, you can see some greenish layer formed over it. See here, like in iron you have reddish layer, in case of copper you have greenish layer. So this greenish layer is rust. So this rusting of copper is due to the formation of copper hydroxide in presence of oxygen and water. So let us see how the reaction takes place in case of copper. Copper reacts with water, carbon dioxide plus oxygen. So this basically represents moist air. So that means the air has moisture in it. So this forms copper hydroxide, which is CuOH whole 2 plus CuCO3, which is copper carbonate. So due to the formation of this copper hydroxide, we see these green color rust in case of copper. So this is how rusting happens. So copper undergoes rusting when exposed to moist air. Now you see all the metals, they react in presence of oxygen. So that's how it is when we talk about reaction with oxygen. Now the next question that comes to our mind is, are these metal oxides acidic or basic in nature? So these metal oxides, whether we talk about magnesium oxide or we talk about copper oxide, we talk about aluminium oxide, so all these oxides, they are acids or they are bases. Now acids and bases are defined by their pH value. Now how do we test whether a particular substance is acidic in nature or basic in nature? Now we will follow the simple litmus test. You remember the litmus test? What happens in the litmus test? Okay, so in litmus test we have a litmus paper like this. Now there are two types of litmus paper which are available. One is called red litmus, the other is called blue litmus. Now if any solution is, so what you have to do is you have to dip the litmus paper into the solution, and based on the change in color you can say whether the solution is acidic in nature or basic. So now what happens in this test is that if the red litmus turns blue, that means the solution is basic. And if the blue litmus turns red, that means the solution is acidic. So this is the simple funda of the litmus test. So this is how we can determine whether a particular solution is acidic or basic in nature. Now in this section, our aim is to find out whether metal oxides are acidic or basic. So how do we do that? So first of all, we have to prepare a solution of metal oxide. That means we have to combine the metal oxide with water. So how do we do that? So let us take example of any metal oxide. For example, I take say magnesium oxide, correct? So how was magnesium oxide formed? when the metal, that is magnesium, combined with oxygen, it formed magnesium oxide. So how do we get this magnesium oxide? So now if you perform the same experiment, you burn magnesium ribbon, you get what? You get ashes. So the ash which you get, that is nothing but magnesium oxide. Now take this ash, mix it with water. So you are basically getting a solution. Now in that solution, so basically this solution is ash plus water. And what is ash? Ash is nothing but magnesium oxide. That is how you have prepared this solution. Now in this solution, you dip a red litmus, and what do you see? You see that the red litmus has turned blue. So you see, this was the original color of the litmus paper, but this portion has turned blue. So this shows that this solution is basic in nature. So we conclude that metal oxides are all basic in nature. Now if you try this experiment out with other metal oxides, there also you will receive the same result. If you want, you can try it out with the iron oxide. For example, you take some rust. If you find any iron material which has undergone rusting, where you can see rust, take little bit of rust, that red powdery thing, and then try to mix it with water. Even though it will not get mixed properly, but at least you try to mix it to a large extent, and then you dip the litmus paper, and you will see that case also the red litmus will turn into blue, which shows that the rust is also basic in nature. So we conclude that all metal oxides are basic in nature. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on metals and non-metals part 9 is brought to you by examfear.com. No more fear from exam. Now what about non-metals? So we spoke about metals. What happens when non-metals are exposed to air? So non-metals also combine with oxygen to form oxides. But in this case, the oxides are acidic. So we will see how it is acidic and all. So let us take some examples of non-metals. For example, sulfur. Sulfur combines with oxygen to form sulfur dioxide, which is a gas. Carbon, which is a non-metal, combines with oxygen to form carbon dioxide, which is again a gas. Hydrogen combines with oxygen to form what? To form water. So you see, everywhere it forms oxides. Now our next question again is going to be whether these oxides are acidic or basic in nature. So now the question is, are these non-metal oxides, they are acidic or basic? So when I say non-metal oxides, I am talking about the sulfur dioxide gas or the carbon dioxide gas which was formed. So are these acidic or basic? So for that again, we will follow the same litmus test, and for that we need a solution so that we can dip the litmus paper. So how do we prepare a solution? We will mix these with water to prepare a solution. So when sulfur dioxide is mixed with water, it forms H2SO3. That is, okay, we will tell the name later. Similarly here, when carbon dioxide combines with H2O, it forms H2CO3. And then what happens? Then it is found that when the litmus paper, the blue litmus, is dipped into the solution, it turns red. This shows that the solution is acidic in nature. So non-metal oxides are acidic. So what are these compounds which are formed? H2SO3 is nothing but sulfurous acid. What is H2CO3? It is nothing but carbonic acid. So all the non-metal oxides are acidic in nature, whereas the metal oxides were basic in nature. Now if you want to try for some other oxides, for example nitrogen oxide, when it combines with water it forms nitrous acid or nitric acid respectively. So that's how we can see that all the non-metal oxides are acidic. So this is again another difference between the behavior of metals and non-metals. So now comes reactivity of metals. So we saw that different metals, whether it is metal or it is non-metal, they all react with oxygen. But when you talk about metals, it has been seen that different metals react in different ways. So different metals show different reactivities towards oxygen. Like some of them react very fast with oxygen, some of them react very slowly, some of them even do not react at all. So here we will see that how different metals react with the same oxygen in different ways. So let us take examples of these metals, potassium and sodium. Now these metals, they react very fast. So they react very fast. So they react so fast that they can even catch fire if they are kept exposed to air, because air contains oxygen. So whenever you keep them exposed to air, they will immediately react with air and they produce so much of heat that you can actually see fire. So it catches fire. So it is that reactive. Now you take example of another metal like iron. So in case of iron, it does not burn on heating. So iron itself doesn't burn when heated. So when you are heating means you are basically supplying oxygen. So it is the reaction of oxygen. But if you take iron filings, that is small powdery iron filings, they burn when they are sprinkled on flame. So here you can see iron and iron filings, they both behave in different ways when heated. Again, if you take examples of gold and silver, gold is aurum and silver is Ag. So if you take examples of gold and silver, they do not react with oxygen even at high temperature. So there is no reaction with oxygen even at higher temperature. Even if you keep on increasing the temperature, even then also there will be no reaction. So that is why you would have seen that the gold and the silver jewelry, they are all exposed to air all the time, but nothing happens to them because they do not react with oxygen. Again, if you take examples of metals like magnesium, aluminium, zinc or lead, so all of these metals, they are all covered with a thin layer of oxide, and this oxide layer acts as a protective layer and prevents any further oxidation of the metal. So it is like there is a protective surrounding. So that protective surrounding will not allow the metal to react with oxygen. Basically, it will not allow oxygen to come in contact with the metal. So there would be no further reaction. So that's how different metals will react differently, and in a very similar way, not only with oxygen but with other things also. For example, reactivity with water or with acids or with bases. So we will see that the behavior will be little different for different metals. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on metals and non-metals part 10 is brought to you by examfear.com. No more fear from exam. So now we are going to talk about reaction with water. So we already spoke about oxygen. Now let us see how do metals react with water. Now, under normal conditions, metal reacts with water to form metal oxide, but along with that it releases hydrogen gas. So that is how they normally react, normally all metals. And these metal oxides can further combine with water to form metal hydroxide. So basically, when you put a metal into water, it will immediately form metal oxide and some hydrogen gas. And this metal oxide in turn will again react with the water to form metal hydroxide. So by the end you will receive all metal hydroxide. But an important point to note is that all metals do not react with water. It is not necessary that every metal will react with water. Now we are going to talk about some of the metals and we will see how they react with water. So we will talk in terms of their chemical reaction. So let us first consider the first metal, that is sodium, which is Na. So let us see how sodium reacts with water. The sodium again is very reactive. I told you before also, right, that these metals like sodium and potassium, they are extremely reactive. So sodium reacts vigorously and it reacts very fast with water. In this case also, if sodium is exposed to little bit of water, it can catch fire. So therefore, in your chemistry labs, all these metals are stored, right? But sodium is stored with special care because if you leave it exposed to air, it will catch fire. If you put it into water, or if by any chance moisture comes in contact with it, then also it will catch fire. So how do you store sodium or potassium? They are stored inside kerosene oil because there is no water, there is no air, so there is no reaction. So that's how sodium is stored, and you should be extremely careful, little extra careful in fact, while you handle sodium. Now what would be the reaction when sodium reacts with water? So Na plus H2O, what does it form? It forms metal oxide plus hydrogen. Correct? But this metal oxide will again react with water to finally form metal hydroxide. So what would be the final product? One is hydrogen gas will be released and the second is metal hydroxide will be produced. So in this case, it will form sodium hydroxide, that is NaOH, plus hydrogen gas will be released plus lot of heat energy. Now, the heat energy which is released in this reaction is so much. So, the heat energy is so much that this hydrogen gas which is released, it catches fire. So, the hydrogen gas catches fire, and that is why if it comes in contact with moisture or water, sodium catches fire. So, in this case, this water is nothing but cold water, normal cold water. So, even little bit contact with water can actually result in fire with sodium. Now similarly, if you look at the reaction for potassium, that is K. So what happens in that case? Potassium plus water, it forms potassium hydroxide plus hydrogen gas plus heat energy. So in this case, this hydrogen which is released, that is released in gaseous form. And what is this sodium hydroxide and potassium hydroxide? They are in aqueous form, that is aqueous solution, you can say. And this water is of course liquid. Here also water is liquid. So because of so much of reactivity, sodium and potassium are always stored in kerosene so that it cannot react either with oxygen or with water. So this is how these metals react. Now that doesn't mean that all the metals will react so vigorously with water. In fact, some of the metals will not react at all. So let us go ahead and look at some other metal. So the next metal that we are going to consider is calcium, that is Ca. So let us see how it reacts with water. So calcium reacts with water. So this will also form metal hydroxide, that is CaOH whole 2, calcium hydroxide, and hydrogen gas will be released. But in this case, the reaction is not as violent as sodium or potassium. So the reaction is less violent, and the heat energy released in this case is not that much that it can catch fire, that hydrogen gas can catch fire. So less amount of heat energy is released during this reaction. But here also calcium can react with cold water. Like there are some metals which do not react with cold water, but when you heat the water, they tend to react. So, but in case of calcium, they react with cold water. The next one we are going to talk about is magnesium, that is Mg. Now when magnesium reacts with water, what happens? Now here in this case it depends. Magnesium does not react with cold water. So if you put magnesium inside cold water, nothing will happen. There will be no reaction at all. But instead of cold water, if you put some hot water to magnesium, then what happens? Then reaction takes place and magnesium hydroxide is formed. Now in many cases I am not balancing the equations, so please you do that yourself. So in this case, magnesium hydroxide will be formed. So reaction takes place only with hot water. So let us look at some other sets of metals. So the next metals that we are going to consider are aluminium, iron. So let us see how do they react with water. Now these metals, they do not react with cold water. So if you put them in cold water, there will be no reaction. Okay, so let us try with hot water then. It might react with hot water like how magnesium did. But in this case, we see that they don't even react with hot water. Okay, that's surprising. But now instead of hot water, if we take steam, that is boiling water, the water is boiled, so that is steam, then we see that it reacts. So how the reaction looks like? So the reaction is somewhat like this. Aluminium reacts with steam. Now this H2O is nothing but steam. So it is gaseous form of water. So this forms aluminium oxide, that is Al2O3, plus hydrogen gas is released. So if you want to balance the equation, here you go. Now similarly, iron, it reacts with steam, which is in gaseous form, to form iron oxide, that is ferric oxide, plus hydrogen gases released. So this is how metals react with water, like this set of metals, aluminium and iron. So that's one way of reacting with water. Again, if you consider metals like lead, copper, silver, gold. So if you consider these metals, do you know how do they react with water? They do not react with water at all. So for these, they do not react, whether it is cold water or it is hot water or it is steam, they do not react at all. So what did we conclude based on our study on reaction of different metals with water? We see that it really depends from one metal to another. Some metals are so vigorous, they react very fast with water. Some react with cold water, some react with only hot water, some reacts only with steam, and some do not react at all. So based on whatever we have learned so far, we saw that metals like sodium and potassium, they react with cold water itself, and that too they react very vigorously, so vigorous that it catches fire. Whereas metals like calcium, they react with cold water, but it is not that vigorous, so it is less violent. So in this case, the reaction is less violent, so there is no fire and all. Next is magnesium. Now magnesium do not react with cold water, it reacts only with hot water. Next comes aluminium and iron. Now they do not even react with hot water, they react only with steam. And finally, these metals like lead, copper, silver, gold. So these metals do not react with water at all in any form. So the metals vary this much in their reactivity with the same substance. So now let us see how do non-metals react with water. Now you will be surprised to know that non-metals do not react with water. For example, your carbon or sulfur or nitrogen, they do not react with water at all. In fact, those metals which are highly reactive with oxygen, for example, there are certain non-metals which are very much reactive with oxygen. For example, phosphorus. So whenever phosphorus is exposed to air, what happens? It is highly reactive. So it combines with oxygen to form oxides of phosphorus. So phosphorus is highly reactive in air, that is in presence of oxygen. Therefore, but at the same time it doesn't react with water at all. Therefore, phosphorus is stored in water. So see, that is another interesting fact. So this is how we store phosphorus. So just see, inside you have white phosphorus. So because we already learned, right, this phosphorus is so reactive that if it is exposed to air, it can catch fire very easily. So to prevent that, it is stored inside water, inside a bottle. So now it is no more in contact with air, and anyways it doesn't react with water. So this is again another point of difference between metals and non-metals, that metals react with water and non-metals do not. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on metals and non-metals part 11 is brought to you by examfear.com. No more fear from exam. Now we will see how metals react with acids. So now let us see how do metals react with acids. Here also we will see that different metals react with different acids differently. So even if you take the same acid and make it react with different metals, the reactions will be different. If you take different acids with the same metal, in that case also the reactions will be different. So basically it depends on which particular metal is reacting with which particular acid. So let us take examples of few acids for better understanding. So let us say for now, let me take a dilute acid, say dilute HCl, that is dilute hydrochloric acid. Now normally what happens is, if a metal reacts with a dilute acid, so with any dilute acid, this is a normal scenario but doesn't mean that it will be true for all the metals and all the acids. Then it generally forms a salt and it releases hydrogen gas. So that is the general trend. However, the reactivity of various metals are different. For example, now let me give you example for some metal, the same reaction. Let us take example of magnesium. Now when magnesium reacts with dilute hydrochloric acid, this is dilute, it forms a salt, that is magnesium chloride, and hydrogen gases released. Now this reaction might not hold true for all the metals. That's because magnesium has the highest reactivity with dilute hydrochloric acid. So if you try to arrange the metals in terms of reactivity, then magnesium has the highest reactivity, then comes aluminium, then comes zinc, then comes iron, and then comes copper. In fact, if you talk about copper, copper doesn't react. There is no reaction of copper with dilute HCl. So it doesn't react with dilute HCl at all. So right now I am talking only about dilute HCl. So this series which I have written, this is true only for reaction with dilute HCl. So see, even with the same acid, the reactivity of different metals are different. On one hand, magnesium is highly reactive with dilute HCl. On the other hand, copper doesn't react at all. So let us take examples of some other acids as well. So the next acid that we will consider is aqua regia. This is a very interesting acid. Now this is actually a combination of two acids. This is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio 3:1. So that means 3/4 of it contains concentrated hydrochloric acid and 1/4 of it contains nitric acid, that is HNO3, and hydrochloric acid is HCl. So that is aqua regia. The word aqua means watery, and aqua regia means royal water. Now, why am I talking about such a special type of acid, which is a combination of two acids? Now you will see that how it acts. It acts really magical. It has something very interesting associated with it. So that's what we will see. Now this acid, it is highly corrosive in nature. It can dissolve even metals like gold and platinum. That sounds interesting. So this acid can dissolve even gold and platinum, because you saw gold is one such metal which do not react with water, which do not react with air, right? So normally it doesn't react with anything much, but this particular acid can actually dissolve gold also. So now you will get to know how exactly have you ever seen that when a gold jewelry becomes very old, maybe some 40-50 years old, now you want to get it polished. So what do? You take it to the jeweler shop, give it to him, and he polishes it, and it shines like before. So from where does that shine comes? How does he do this polishing? So that is where aqua regia plays an important role. So let us see how exactly gold reacts with aqua regia. Now this is gold AU. Gold reacts with aqua regia, and aqua regia is nitric acid plus hydrochloric acid, that is HCl. So when it combines with this, it forms AuCl4, that is gold chloride, chloride of gold, plus NO2 plus H3O plus H2O. So this would be the complete reaction. Correct? So what do you see? You see earlier it was gold, but on reacting with aqua regia, gold formed gold chloride. So basically it got dissolved in the acid. Correct? Now I will show you the picture how gold can get dissolved and how you can get pure gold precipitate produced by aqua regia. So see, this is a pure gold precipitate. This is the gold which we normally see in the form of brick, in the form of jewelry, but this is the precipitate of pure gold which is produced by aqua regia. So aqua regia can actually dissolve this gold like this. Now when you give your jewelry for polishing to shop, what they actually do is they dissolve it in aqua regia, and this aqua regia, they take down a thin upper layer of that jewelry. So because it can dissolve gold, right? So the upper layer of gold is dissolved, and therefore the below layer is displayed, and the below layer obviously has the same shine because it was not exposed. So that is how polishing of gold is done. So if you observe it more carefully, you would see that after polishing, the weight of the jewelry reduces a little bit. That's because one upper layer of gold is dissolved. So this is another important acid, and we see that how metals. In fact, platinum also reacts in a similar manner with aqua regia. So now we will see another acid, that is nitric acid. So now we are going to talk about nitric acid. Now nitric acid is a very strong oxidizing agent, that is it can oxidize anything. So while reacting with acids, what do metals actually do? We already saw the example of two acids, dilute hydrochloric acid and aqua regia. But basically what metals do is they reduce hydrogen ions to form hydrogen gas, and that is how hydrogen gas is released during the reaction. That is what they are actually doing. Correct? Now in this case, nitric acid is a very strong oxidizing agent. So what is nitric acid going to do? We will see that. So this nitric acid oxidizes the hydrogen produced to water, and itself gets reduced to any of the nitrogen oxides. Now normally, under normal condition, what happens? Hydrogen gas is released. Correct? But in this case, because nitric acid is very strong oxidizing agent, it will oxidize the hydrogen gas which was produced to water, and it itself will get converted into one of these oxides, nitrous or nitric oxides. Now let us see some of the reactions with different types of nitric acid. So first start with dilute nitric acid. So dilute HNO3. So let us see how metals react with dilute nitric acid. So let us take example of some metal. For example, let us say I take magnesium. Now when magnesium reacts with dilute nitric acid, please remember this is dilute. So it forms magnesium nitrate, that is MgNO3 plus hydrogen gas. So in this case, hydrogen gas is released. Why? Because here it is dilute nitric acid. So it is not that strong oxidizer. So therefore the metal here, what did the metal do? The metal reduced the hydrogen ions. So from here it took the hydrogen ions and it formed this hydrogen gas. So that is what metals normally do when they react with acids. Now let us suppose if I keep everything same, just that instead of dilute nitric acid, if I take a nitric acid which is like moderate nitric acid, neither very dilute nor completely concentrated. So I take say moderate nitric acid. Now in this case, how the reaction changes? Let us try to see. So here also magnesium will react with moderate nitric acid to form magnesium nitrate, that is MgNO3 whole 2 plus NO nitrous oxide plus H2O. So if you want to balance the equation, you can do it like this. So in this case, what happens? You see, earlier hydrogen gas was released, but now that hydrogen gas is oxidized to form water, and what happened to the nitric acid? The nitric acid got reduced to nitrogen oxide, that is NO. So that is the difference now, because now the concentration has increased a bit when compared to situation 1. Therefore, in this case, instead of hydrogen, we have water that is released, and we also have nitrogen oxide which is being formed. Now in the third scenario, let's say I take completely concentrated nitric acid. So what will happen in this case? So this case, the nitric acid is going to be a really strong oxidizer. So it is going to form magnesium nitrate, will remain as it is, but now instead of nitrous oxide, we are going to have nitrogen dioxide, that is NO2 plus H2O. So this is how the reaction would be. So in this case, you have NO2. So you see, as the concentration of nitric acid increases, the oxidizing effect of nitric acid also increases. So this is how magnesium reacts with nitric acid. Now, this doesn't mean that every other metal will react with nitric acid in a similar way. For example, there are certain metals which do not react with dilute nitric acid. For example, so let me give you the examples. Let us say magnesium, manganese. All these, they do not react with dilute nitric acid. So if you mix them with dilute nitric acid, they will react. So these will react, but there are certain metals which do not react with dilute nitric acid. So let us take some other examples. Some metals which react only with concentrated nitric acid, and one such example is copper. So copper reacts only with concentrated nitric acid, because concentrated nitric acid is a better oxidizing agent. Now copper reacts with HNO3, and what does it form? It forms copper ions plus NO2, that is nitrogen dioxide, plus H2O. So this is how. So the reaction is little similar to that of this reaction, correct? But copper doesn't react with dilute nitric acid. It prefers to react with concentrated nitric acid. So there are some metals which react with dilute nitric acid, but they do not react even with but they also react with concentrated nitric acid. However, there are certain metals which do not react even with concentrated nitric acid, and such examples are zinc, aluminium. So if you ask zinc, aluminium to react with concentrated nitric acid, they do not react. So basically what I am trying to say is different metals have different reactivities towards nitric acid. Okay, so you take examples of magnesium and manganese. These two reacts with dilute nitric acid. They also react with moderate nitric acid. They also react with concentrated nitric acid. You take example of copper. It reacts only with concentrated nitric acid. You take examples of zinc and aluminium. They do not react even with concentrated nitric acid. So it depends how metals will react with a particular acid. But whenever a metal reacts with an acid, the motto of the metal is to reduce the hydrogen ions to release hydrogen gas. So that's how it happens normally. So now let us see what happens to non-metals. How do they react with acids? Now again you see that non-metals generally do not react with acids. Please make a note of this point, that they generally do not react, because there are certain non-metals which do react with acids under certain special conditions. But in general, metals react with acids to release hydrogen gas, but non-metals do not react. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.